participants who have registered. So
Yes.
really looking forward to this session and hope to deliver some value.
Definitely so.
So before we begin, like any questions anybody has, any thoughts, comments?
That operates in a cycle. That operates in a cycle.
So maybe like we'll wait 2-3 more minutes. So we'll start at a little over 4.
So we'll wait for 5-10 minutes as 4 p.m. is the joining time. People join in time, and then
Sure,
Shivam and Upasna will sort it, and we'll do the 4 in a few minutes, 5 minutes maximum.
sure.
Okay.
So most of the students over here, or most of the people over here, are students from DTU, or are there some people from outside as well?
No idea, sir. As of now, we'll get to know as the session proceeds.
Right, right. Yeah, like I have a couple of Slidos which will be there. So maybe like there'll be some questions which might come up.
Yes, sir.
So yeah, maybe I'll just even before we begin, probably like I'll just post that. So can you folks see what exactly like I have posted?
Yes, sir.
I have slowly started seeing the results. So everybody can participate in that Slido. I'll
Okay,
post
sir.
it. So for the benefit of everyone, like I'll just share the screen as well. Um,
So wait for a few minutes, sir. So
sure.
wait for a few.
Okay, I'll just. Okay.
Yes.
Mhm. Hello, sir.
Hi, Upasna.
Sir, I'm audible.
Yes, you are audible.
Sir, we are going to start now.
Okay, sounds good. Um, yeah, so I'll
So
just,
we have some short introduction and some introduction of yours. After that, you can take over the screen.
sure, sure.
Okay, thank you so much, sir. Okay, so good evening, everyone. I, Upasna Singh, alongside with my co-host Shivam Chauhan, welcomes you to this highly anticipated life cycle analysis workshop conducted by Society for Civil and Environmental Engineers.
The Society for Civil and Environmental Engineers (SCEE) is the oldest technical society at DTU that works towards providing practical and innovative paths of learning in the field of civil and environmental engineering. The society was founded in the year 2009 with the aim to provide its members with various opportunities participating in the events and bestow practical knowledge in the field of civil and environmental engineering. We have assembled here to delve into the realm of life cycle analysis and explore its significance in evaluating the environmental impact of products and systems. Through its workshop, our objective is to deepen our comprehension of sustainability and foster informed decision making for a more environmentally friendly future. Upasna, you are mute.
Sorry, sir. So, without any more delay, let us commence this journey together with our esteemed industry expert, Mr. Nishant Arora. Mr. Nishant Arora is a certified energy manager and data center energy practitioner with a background in electrical engineering. Sir has over 20 years of diverse work experience and in depth experience in multi domains, leading winning teams, strategy planning, and road mapping with analytical, detail oriented, data driven, and entrepreneurial in nature. He began his professional journey as a project trainee at ISRO, followed by an engineer at ESSAR Group. He has also worked with Tata Consultancy Services in Amsterdam and Brussels. Seeking new opportunities, he started working as the Chief Strategy Officer at Surya Conversion LLC USA. Currently, Mr. Nishant serves as the founder of Core and Ecotech. He is also a proud member of esteemed organizations like the Indian Institute of Corporate Affairs and the Association of Energy Engineers. His profound knowledge of life cycle assessment methodologies, coupled with his multidisciplinary approach, makes him the ideal candidate to provide our students with an engaging and practical session on LCA. Now, we would like to open the floor for Mr. Nishant to take forward the flow of the event.
Yeah, thanks so much, Upasna and Shivam. Really appreciate you with the introductions. So I'll just share my screen. Just let me know if you can see that we are in presentation mode now.
Yes, sir.
Great. So yeah, I'll try to have this as a hands-on session with OpenLCA. So we kind of have a 1 hour timeline. So I'll try to stick to a schedule with that. Um, so I've kind of broken up into four parts. First will be kind of a presentation, then it will be manual LCA. Third would be the software demo, and the final part actually would be Q&A, but also the challenges which are there within the LCA in India. So moving forward, so what exactly is an LCA? So LCA, according to me, is like the gold standard for any environmental impact which needs to be taken, and it can be for any product, process, or services, and it covers like all stages of the life of a product, service, or process. So it's both an art and a science, and requires a lot of rigor. And what it really requires is credible data, tools, some research, and some experienced professionals who might have experience, who can share their experience with you. So I wouldn't say like I am an expert on LCA. Like I did it maybe 10 years back, but what I do know is like I did it very well. This was part of my MBA program at University of Colorado Boulder. So we actually worked on a live, you know, project. So I'll just come to that. But like what we learned over there was it was based on ISO 14040. It's part of the ISO 1400 family. And what really it is it's depending on something called as plan, do, check, act, uh, kind of a cycle. So it's a process which is continually improving the triple bottom line. So maybe I'll just show the ISO 1400 family, which is kind of related to LCA, like how it fits in to the whole approach which is over here. So as we see, like the ISO 1400 family is kind of so this document basically is from ISO. Like some of these are like €500 or even greater costs which are there. So this is the whole family of standards which are there, and within that, like if we see that so 14040 is in the do mode, but then like we will also be referring to 14044, which is kind of defining the requirements and guidelines. And furthermore, like we will also be getting into the principles and procedures which are there, so environmental declaration. But all these actually in the whole process they come into play. And if I was to talk very specifically about 14040, so this is the international standard. So at the end of this session, like probably I'll be even sharing these. Keep it to yourselves. Work with this as students or enthusiasts within this space. But what LCA is, it basically consists of 4 phases which are here. So I'll go back to the slides, continue from there. So you'll actually see me today, go a lot back and forth. So what exactly LCA was is it's not just carbon accounting. Carbon accounting is becoming big today because of the climate change impact which is there, and every nation is trying to reduce their carbon footprint. Every nation, every company is working on that. But there are other environmental hotspots, say water, hazardous chemicals, and even negative impacts on the planet. Say for example there could be negative impacts on, say, biodiversity. So so there is a holistic approach which is kind of required. So as we saw in the ISO 14040, there are like 4 phases of LCA. So the first phase basically is defining the goal and scope. So what exactly is your goal with the LCA? Are you looking at scope 1 and scope 2, or is it also a requirement that you're looking into scope 3? And what are kind of the impacts you would like to study further in detail? So this is an effort which is there. So it will have lots of data inputs and data outputs. So it's actually an expense. So your goal is kind of defined by the budget which is there. So for all the professionals who are actually seeing this, they might be looking into kind of defining and refining the goal before delving into such kind of a project. Once you have defined the goal and scope, you have the inventory analysis phase where, say, for example, if you have a particular process, you understand the process completely, and then get into the details of what exactly are the inputs, and then look at the inputs from upstream and then the outputs from the downstream. So we'll be looking more into detail of the LCI, which is the inventory analysis. Then furthermore, like we'll be looking into the impact assessment phase. So what exactly are the impacts of, say, a reagent which is used during the process? if it is a hazardous chemical, could it have downstream effects on, say, plants, or some of the animals, or some effects on biodiversity, or contamination of water, who knows, right? So we need to have a thorough impact assessment. And then finally, interpretation phase is where we kind of tweak the inputs, and see whether the outputs are you know okay for the regulations for the country. So European regulations are pretty strict, and like if you might later on see that many of the products which are used, the software tools which we'll be using, they are based out of Europe, and some of them from the Americas, but mostly from Europe, because there's very stringent requirements which are there. So interpretation will be based on how we can tweak the inputs to meet the goals which are there. So moving forward, so firstly, I'll be talking about the manual method. So in the manual method, what we do is, like in the process which like we looked into, we calculated carbon emissions, we analyzed some of the hotspots, assessed human health impacts. So we did not look into animal health impacts, or impacts on downstream further, with emissions into the atmosphere and stuff like that. And then we analyzed and made efforts to close the loops which are there. So moving forward, so many of you like who are maybe students, like you might be aware, we have scope 1 emissions which are direct, and then there are indirect emissions, like which is mainly electricity, and then there are scope 3 emissions which are upstream and downstream. So I mean, all the technical folks over here, or maybe students, they might be already aware of what the kind of emissions are. So we'll be looking into that. um, so so talking very specifically about the project that I worked on, the LCA which we conducted on. So it was the manual LCA which was done for a cellulosic biomass processing. So there's something called as corn stover. In India, like we call it parali. Basically, when you grow corn or wheat or whatever, so you take out the corn or wheat, the rest of the plant which is there, it is basically biomass. So today, what's being done with it, it is being burnt. It every summer, like many of you from Delhi, like you already know that winters come November, you'll have a thick cloud of smoke, and uh, there are multiple downstream effects of asthma and whatnot which is happening. So a project like this, maybe conducted by some of the students, could actually help. So this was done maybe 10 years back, but it is still applicable today. So what we did was, and like I have an NDA with the particular organization I worked for. So I won't be telling about the liquid reagent, but I'll be telling about some of the other chemicals which we used. So the biomass was put in, then along with that, undisclosed liquid reagent was put in, and also sulfuric acid was put in, and water was there. We also have inputs of high heat and water, sorry, high heat as well as electricity. So it's a process called as CCR. So it's a continuous reactor which is actually working. And as the outputs, reagents which will be recycled, lignin which was there, maybe which could be used for burning, and we got something called a sugar syrup. It's not sugar syrup per se, which can be used in our food, but it is basically certain chemicals which could be used for industrial processes, and there were residual solids which were there. So as you see, there are certain flows which are there, and there are certain processes which are there. So when we do the software approach, we'll be actually looking into it. Like we understood this whole thing from the chief scientist over there. So this was a patented technology which had come up right from the lab, and they were trying to scale it up. So initially they had a 25 kilogram per day uh, process, and then they wanted to scale it up to 25 ton per day, and then 250 tons per day was the goal. So based on those targets, like with the initial data which was there for the the few kgs which were getting processed per day, basically a small setup. That's how like we were getting the initial inputs for the process, and then inputs were extrapolated. So when we understood this thing from the chief scientist, we also were told that Nishant, you need to do some literature review. So because back in the day, these software which were there, they were pretty expensive, and they were not fitting the bill which was there for us students looking into this. So what we did was, we looked into other life cycle analysis. We looked at some publications. We looked at some databases. We looked at the EPA website. So this is the US EPA. Scientific journals, scientific studies, core catalyst tools, web searches, and then discussions with experienced professionals. So while this literature review was done, we were actually looking into specific data which was there, which was kind of related to the process which was there. So, for example, when we use sulfuric acid, so what is the upstream carbon of sulfuric acid? So, carbon equivalent of sulfuric acid. So, we looked into things like that. Um, so going further, maybe into the process. So this was the process where the input metric ton per year, which was predicted, was 320 3,28,500, and then this was this reagent which is basically not disclosed. I'm still under the NDA. But then water was used, and then sulfuric acid was used, and then you mentioned fuel heat. So this is in gigajoules per year. But there is a reason, where it is mentioned as heat. It's not mentioned these many kgs of natural gas. We'll come to this, why we are saying heat as an input. Furthermore, there is electricity as an input which is there. So with this we can basically understand it was being the whole process was under pressure. So a certain amount of uh, pressure on the system was there while this process was being performed, and certain amount of electricity was getting passed while uh, through the whole biomass, while the extreme heat was getting provided. And when we looked at the outputs, so this was mixed sugars and syrup. So 43% solid, 33% sugars, and this is all extrapolated data. I mean, what we are getting from a simple 5 or 50 kg process would be very different than what they would get from a 250 ton process. So we will also like kind of over the process kind of extrapolate. So we'll basically see in the long term whether it's a straight line or it's some kind of a curve. uh, and if it's a curve, whether it's a S curve or a U curve, or what's the whole like extrapolation that's happening. So output also had lignin. So lignin is kind of the solid which is there. So and then there were other solid base which were there, which came out as well. So there was no wastewater, but there was fugitive water. So apparently it because this was happening in extreme heat, and then once the process was complete, that whole heat actually escaped, or the steam actually escaped. So all the water which was getting used was actually considered as fugitive water, or most of it was fugitive water. Some was absorbed by the process, and then there was this chemical reagent which was there. So we assume that almost all of it was kind of fugitive. So it basically left in the atmosphere, and then fugitive CO2 was there. So all these inputs and outputs were there. So if somebody is taking a calculator and doing the math, so they'll see this whole thing which is there, it is 1.6 million ton roughly, and metric ton, and this is also 1.6 million metric ton. So basically inputs and outputs should balance, or more or less balance. Otherwise there is something which is off. So the scientists which we were working with and who were providing us the data were kind of the ones who were trying to fine tune, and all these numbers which were there, they were kind of sometimes extrapolated. So to fit the numbers, what we saw is the fugitive CO2 must have been 52 metric ton. So that's what was figured. So but when we look at the actual process that happened, so what we'll see is, so in the detailed calculations we see is that the total CO2 which was actually released was not 52 metric ton. It was off by 217 times. So uh, so the total CO2 release was this much, and the whole calculations kind of were disbalanced. So this was basically when you're not using a software, it is fraught with elements of what do you call, mistakes, or also like many times a patented process is kind of being defined, but the scientists themselves are not sure whether it is endothermic or exothermic, or water is getting absorbed or water is getting released, or there could be errors in the measuring systems which are there. So practically when somebody is actually you know doing the whole process of inputs and outputs, there could be issues which are there. So considering these were the inputs and outputs, and the fugitive CO2 was coming from from burning of natural gas, which was taken into the process initially. So we kind of try to balance the whole system. So going forward, tweaking the inputs to close the loops. So like as you may remember, the fuel was heat, and it could be natural gas or it could be something else, and in this case it was lignin. So what is coming as output? So as you see, 77,512 metric ton, and lignin over here, the output is 105 metric ton. So most of the lignin which is getting generated at the site, it can be used at the site itself. So it makes more sense to use that. So the organization which we were working with, they had said, Nishant, like you need to work on scope 2 emissions. So when scope 2 emissions are getting kind of considered, and natural gas is getting used, um, if we are, so this is something which is outside the system. So we are bringing in something new into the system, and it is producing less CO2e. But the fact of the matter is that lignin, which was kind of the output which came out from the whole process, that could have been used. So in a way, if this lignin which is an output, it is not getting used anywhere else, not used to make furniture or something else, then, and it's not even getting used as uh, as something which will be used like a fuel. um, we, like, even though this is creating more CO2 emissions, we should still be using this. Otherwise, it's basically, very crafty or very, unethical carbon accounting process, which is, getting followed. So do consider that, like when we talk about sustainability, the first thing in sustainability is ethics. And in this case, what was happening was maybe not right. Like we were clearly told that, we should go with natural gas. We did what we were told, but like if I was somebody who was running the show, then I would probably would have used lignin for the process, because it kind of closes the loop. Moving forward, so we looked at, the GHG outputs which were there. So as we see, the energy inputs were there, heat, electricity, and fugitive CO2 emissions. And from that, carbon equivalents which were there. So we actually had, natural gas, equivalent to 97,735, as we saw in the previous slide. But we also have, emissions from electricity. So emissions from electricity is 11,182. So upstream carbon emissions from electricity. So those are like pretty interesting. So I would say, like, maybe, we should be diving a bit deep over here, because like I feel, even the LCA tools out there are not doing full justice to it. So maybe I'll jump to a particular section. So as you see, the carbon emissions, like with electricity generation. So this is the average CO2 emission intensity in 2018 for India, electricity generation. So electricity generation, over the day, it keeps, changing, and during the evening, it even, goes to 718 grams of CO2e, so 715. So this is pretty high. Like we assume that, the process is, mainly happening during the day, or it might be happening 24 hours. So like we need to be mindful of, when the electricity is getting used and what's the carbon intensity which is there. So coming back, like we actually had, calculations of um, electricity. So within the calculations of electricity, oh yeah, this is the one. So EPA basically suggests, 7.0555 into 10 raised to minus 4. So if you see, it's roughly the same, So this is 718, and this is 705 metric tons of CO2 per kWh. So this is an average which is there. So over here, like if this was the thing which was getting used, and the average might be something like 660. So this is 10 years back. The US grid has also improved. This multiplier has actually changed. This is called the emission factor. So part of the challenge also, like for India, is that our utilities don't publish emission factors. So in the US today, all different utilities are publishing an emission factor. So you can actually, based on your location, based on your plant site, you can actually figure out what your emission factor is, or what your emissions during the day are, and then based on that, estimate how much is the upstream CO2 which is getting released. So unless and until we have good data, we won't be able to do a good LCA. So going back to the presentation, also looking at the time is slipping past. I'll try to be quick. So looking at the potential hotspots which are there, so there are environmental impacts and there are health impacts which are there. So so there was this chemical reagent which was lost to the atmosphere, and it has environmental impact, yes, and issues are basically of health concern and economics. So if it's an expensive reagent, if it is getting lost in the process, there is economics which is kind of going to drive it forward. So I hope in the last 10 years they have kind of hoped that they might have improved the process of trying to recapture the fugitive reagent which is getting lost. So also sulfuric acid is getting lost, and it is a huge health concern. And finally, the reagent and sulfuric acid could be in the sugars and polylactic acid. Luckily, like, it's not used for human consumption, but it could be in the parts of it could be in the materials which are coming out as outputs. So it although it doesn't have environmental impacts, or maybe minimal environmental impacts which are there because of the low quantities which are there, but still this is answerable by the clients, how much impact is too much or acceptable. Finally, water is lost. So environmental impact, we call it maybe, but yes, it's an impact. So these are kind of the things which came out from the whole process. So I will be kind of sharing at the end of the presentation, like I've redacted some of the portions. So I'll kind of have this whole slides which are there. So and these are maybe old numbers, but some of these numbers don't change, right? And their usage of tonnage is different, metric ton or short ton. So like those things remain constant, but yeah, there are few good inputs which are there. Also, like, there will be some certain calculations which we have done. So for example, like lignin which is there. So you might have, if you recall, we actually did a literature review, right? So why did we do that literature review? It was for things like these. So if we did not dig into deep, what exactly that is the molar mass of the lignin. So we figured out that these are the three elements of lignin which are going to be there in corn stover, and roughly almost in equal quantity. So this was kind of an average. Then we took of 180 grams per mole, which was used for further, these calculations which are there. So all these calculations which are there, they might, give you some idea and maybe, help with your future projects. So yeah, I guess, like, I'll get back to the presentation. Yeah. So this was 10 years back. There are so many LCA tools out there. Um, I mean, due to cost, Open LCA is the tool which is preferred. Back in the day, like, apart from the manual process which we use, we are curious enough to explore Gabby. So Gabby software was kind of the gold standard back in the day. Today, people are using Sima Pro because it's online, and there are very many benefits of this tool being online. There are a bunch of tools out there, and this is a list from 10 years back. So I'm sure this list has increased way beyond. So I mean, tool is one thing, but it's the data where we actually lack. So I'll actually give an example. So what exactly happened back in the day was, like, all these LCAs which are there, they actually need to be having kind of a database. So we'll actually come to databases and stuff with the Open LCA. But the LCA in India was actually supposed to be done by the India LCA Alliance. So this is actually driven by FICCI, and we see that that whole work which was getting done by FICCI was kind of stalled in a way around the time when COVID hit. So 2019, 2020, like, we hardly saw anything in 2020 and beyond. So the whole process which it seems where databases had to be created, that kind of is completely absent, at least in the research which I did in the last few days. So, like, I'm not an LC expert, as I say. So because, like, I have not been doing this hands on, but with whatever I could find, this is something which probably, like, we could reach out and revive. So maybe at the end of this we could actually form a group and then try and revive this and maybe work on this further. So going to Open LCA. So Open LCA, okay. So Open LCA, what we'll do is like we'll download Open LCA. So when we go to downloads, typically you will have an installer which is there. So this is around 300 MB, 290 something MB. So you install the 64-bit on your Windows computer and you can get started. So, but there are also other things which you'll see: LCA collaboration server and impact methods, data quality systems, and format converter. So I want to draw your attention, like maybe to format converter before we jump into the Open LCA tool. So the format converter basically uh, is 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 basically trying to convert one format of data to the another format of data. So today there are different formats of data which are there. So one is uh, being considered by EcoSpold, which is there. Then ILCD is another data format which is there. So there are also like other formats which so there are three formats which like we have, like I'll come to that. So which we can interchange, and this tool basically can be used for that. But also like going back to these other things which are there, the LCA collaboration server. So this collaboration server is where a large group which is there. So maybe if for India, for example, all of us from different parts of the country are actually coming together. So it might make sense to collaborate on an LCA server, and then pick out processes which are there. So for example, like we are looking at a agri process which is there, agriculture based process, which is actually a real world issue for us. With every November we are actually having a great amount of smoke in the air. So we can collaborate with this LCA server, where we can create the database for upstream and downstream processes which are there. So also like there is something called as Ask Open LCA. So Ask Open LCA is basically for it's kind of a forum. It's pretty old school, but this is something which actually works. But then when I search for India, what I found one, two, three, four, five, not even 10. I can count on my fingers. How many entries were there. And I hope like after this session, like we can start collaborating on Ask Open LCA and maybe collaborate among ourselves as well. Ask questions and maybe answer over here, and maybe get answers from experts. So there are people who are asking about different processes which were there. And we saw India LCA was doing some stuff for jute, for example. Jute, castor oil, they were part of processes they were looking into. And they were looking into cement and stuff. So for all those systems or processes or products which are there, like if we have any questions, we organize them over here, and it kind of becomes a handy reference for everyone. So like I'll recommend you using Ask Open LCA. We talked about the LCA collaboration server already. So we'll move forward from that. And we have talked about the format converter. And okay, yeah, maybe in the format converter, like a couple of things, maybe like I wanted to cover further. So we talked about ILCD, right? So ILCD has some resources. So there is general guide for lifecycle assessment. Okay, it's very old, maybe 13 years old, but it's still relevant. So like I was reading through them, and I found things which are relevant. Maybe like I'm not that great updated, but I would still say like I found them very relevant when I looked at the handbook which was there. Um, so we can make a handy reference of that. Also, like the data exchange, which is there based on EcoSpold, which is there. So that is something which is also something which we'll be accessing, and hopefully, like we'll be having something from the India LCA Alliance in future. So to begin with, who is basically creating? So maybe close open LCA. Don't save. So I'll open LCA, and we'll see Green Delta over here. So Green Delta is actually the German firm which is actually doing the LCA. It's basically creating the open LCA software tool. And I see there have been so many multiple changes which have happened. So we are currently in open LCA version 2, and back in the day we used to have versions previous to this. So the most important thing basically is understanding what exactly is the database. So as we saw, like we had some amount of calculations which are there, and like within our calculations we saw EPA, for example, like what is the metric tonnage over here, or maybe like there is something related to processing of alternative lignin as a fuel. So different databases could have different credibility and numbers out there. So referencing the correct database or applicable database becomes very important. So so what we'll do is like we'll actually click on new databases. So when we begin, this is actually really empty. So we don't have any databases per se. So what we do is we click on new database, we give it a name, and then what we have is, say, like I gave this name, cellulosic biomass. So within a database, so this is an empty database over here. So we actually will have some projects which we'll be creating and working on. Then there'll be also product systems which will be there, and apart from product systems, there'll be processes which will be there. So I'll they explain them in further detail when I look at the other database which is there. Then flows are there. Flows are very important. So flows need to be defined. Like maybe like if you recall this process flow, so biomass is going in, and the residual solids are coming out, and the process which is there is heating and passing electricity and putting it under pressure. So the flows kind of are the processes are defined. Say giving heat was the process, and the flow is basically the outputs which are getting defined. And then we have the EPDs. So EPDs, like if you recall, like EPDs actually came in ISO 2025. So these are in environmental declarations which are there. So maybe taking a step back further. So as we saw, there are 4 phases. It is in the interpretation phase which actually this comes in. So what we have done is you actually looked at the planning cycle. So you planned for doing an LCA, and then like you used the ISO 4040 framework to create an LCA, and then you tweaked it, and then you actually had something which could be used for compliance. So that's what is basically been looked into, so by the environmental declarations which are there. So every company which kind of has a declaration, if something changes, what happens is it becomes a corporate governance issue. So one has to be very careful in actually doing these. And overall, this whole process of LCA which is there, it is typically done by third parties. So it is highly encouraged to be done by third parties, because there is a certain amount of credibility. So if a LCA is getting done in house, it has no credibility, because people are maybe fudging the numbers, or making up the numbers themselves. Whereas if a third party is actually doing it, it has far more credibility, because they won't get influenced by the motivations. Maybe it is economic motivation, whether it shares or whatever, right? So if somebody as a third party is getting contracted, so they won't be influenced. So I see many of you who are like in this session might be going forward and starting your LCA organizations. So yeah, looking forward definitely to that. So, but EPDs was there, and then finally the results are there. So the indicators and parameters, background data. So let's maybe look at some actual data which is there. So we defined processes. So we'll maybe look at one dummy process and then look at cellulosic biomass. I call it CB. So for example, like we were looking into electricity, right? So with the electricity process which is there, we actually define what. So like within a defined process, we'll actually have you know uh, the inputs which are there. So we need to attach a flow schema with this. So we add this. We probably add a social schema if there is, and process schema. So we basically consider these, and based on this, we'll see some inputs and outputs which are there. So currently, like electricity carriers which are there, carriers and technology. So amount of one unit of electricity, 1 kWh is 1 megajoules. Hmm. Let's maybe look into tweaking this, so we can actually change this, update this based on whatever is defined as per the process. So these are inputs which are there. So as you saw in the previous you know uh, this one, so where we had an input of 52 metric ton, and instead of that we had to put in this. So this whole calculation actually goes for a toss. So when we had this inventory, we could actually in a spreadsheet model we could have changed this, but then it's not a static model, it's a dynamic. It has to be a dynamic model, and the spreadsheets are typically pretty static. So that was the reason, like any day I'd be preferring an LCA software tool, where this could in fact even be maybe in Sima Pro this is actually getting real time data. It could be getting data from, say, torrent power in Gujarat, or like in like with your state electricity boards which are there. So they would be publishing what is the amount of carbon which is applicable over here. So dummy processes, like we saw, so there are end of life treatment. So wastewater treatment is there. So we need to define what exactly is going to be the wastewater treatment. So it's kind of the whole process is defined. So generally, these databases which we are creating, so if you're working all by yourself, you don't have descriptions, that's okay. But when you are actually sharing these databases across, so you'll be actually having a, a share file. So I'll basically give, so ZOLCA, so that's kind of ZOLCA, that's kind of the extension of the file which is going to be there for these databases. Typically they are above 100 megabytes. These databases are pretty large. So this one is like 177 MB, for example. So once we upload that, it has various inputs which are there. It could be location. If you change the location, things could be different. For example, wastewater treatment in India might be very different from the standards which are there in Europe, and we might change it to a different location. So we'll close this, but we will be changing this based on various kinds of data which we will be using. There'll be various inputs which might be there, various outputs which might be there. So in this case also, like they are having inputs and output based on wastewater treatment. So phosphoric acid, iron chloride, so this is kind of the input, and outputs are coming over here, and they have different values which are kind of defined. How much helium, for example, would be coming out. So other information, administrative information needs to be there. So so it becomes pretty important, who's the data generator, uh, like the publication version which is there. So the database which is getting used, those are all important. So whenever you are actually doing any kind of measurement, for example, in the field, you should know which instrument you are using, what is the calibration, what is the error on that. So 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 when your final report is going to be there, all those inputs actually count. Even over here, so if somebody is using ELCD database 1.0, uh, they should define what the ELCD database is. Otherwise, it could be giving a totally different result. So again, modeling, there are various validations which are there, and the databases which, for example, in this one, which have been used is the ELCD database, GABI database. So bunch of databases are there. So again, the parameters which are there, the parameters kind of are defined. So zinc is there. So for zinc, red, um, so basically, what exactly is the parameter output which is there. So this is basically, it's not a percentage value. It's I think the total. If we look at this total, it might be, um, I think, let's see, it might be 100 or something like that. Yeah, it should add up to 100, or maybe not. 3. So maybe this is in grams. uh, then wastewater treated, 1 kg of wastewater treated will basically give us how much outputs. So so just imagine your process was looking into cellulosic biomass, and in the process chain it is looking at wastewater treatment, and even things further downstream. So if you basically imagine again, it's basically the company which is reporting over here. So what is the thing which is upstream, what is the thing which is downstream, that becomes equally important, and those are like pretty standard. So when we are looking at these numbers which are there, all we are doing is we are saying is this is coming from torrent power, scope 2 emissions. This water is getting treated by Delhi Jal Board. So Delhi Jal Board, they will have, they'll define arsenic as 3.7 kilograms, into 10 raised to minus 6 kilograms in 1 kg, whereas maybe some other water board would have this as 3.9. So that whole database which is there is kind of the thing which is really missing. We are really feeling the pinch of that. um, so again, so we have social aspects which are there. So these need to be particularly documented. So for example, like when we documented health issues, right, so we talked about asthma. So what is the risk level? So these are, I would say, like these are not vanity metrics, but but these are very important. So like we can edit, and then add information which is there. Add and edit information as needed, and this is kind of the overall impact analysis which is going to be there for every process which is out there. Um, so we looked at processes in detail. We'll be looking at flows. So or maybe I'll basically show how to create flows. So one thing we should be very clear is, so whenever we create a process or a flow, most of the time, like, you won't be able to directly use these processes or flows. You will be creating one. So you should, and this is actually a requirement, you should add a new child category. So this kind of creates a separate database, and then within that you go ahead and then add a new process. If you by mistake add a new process, you don't even know, for example, like where exactly, like it will be getting added to, or even if you know which one got added, it will kind of mess up the whole database. So best is, like if you're working with 3 other folks on a particular project, you create your own database. So creating is add a new child category and then add the new process, or you could import. So in this case, for example, like I created this cellulosic biomass, and within cellulosic biomass, like I looked into sulfur. So we had sulfuric acid, right? So like I need to define what is the amount of sulfuric acid over here. So I'll pick up the numbers from here. So sulfuric acid, this was 10,952. But when I look at my numbers for sulfuric acid over here, I actually have done certain calculations. So the calculation was the sulfur lost in the process is this, because sulfur is sulfuric acid has around 32.69% of sulfur. So based on that calculation, and further, upstream, we saw that, sulfur dioxide, based on their molar masses, sulfur dioxide, 50.052% of it is sulfur. So the atomic weight of sulfur and the atomic weight of 2 oxygen, they kind of, getting compared. So based on that, we kind of know what is the metric tonnage over here. We kind of based on that, provide the inputs over here, and then, further downstream, fill out all the information which is going to be there. We kind of, looked at the details in, say, for example, this wastewater. We need to fill in these details to actually, go ahead further with the process. So all the aspects, including the social aspects, like please don't leave this one. These are very important, especially for a society like ours. Like the social aspects are the most neglected ones. So one should be addressing them as well, because they don't calculate as numbers. Like rest of them calculate like numbers. We multiply, we divide, we add, we subtract. But social aspects are something which, need to be addressed as well. And once we add them, we might then in future, as a group, come up with, say, there is a cancer cluster in this area, or there is asthmatic cluster in Delhi, for example, right, because of this pollution which is happening. So all those social impacts will be coming in, and it will, kind of so it will be populating the impact analysis. So you'll be defining the process, you'll be defining the flows as well. So you'll have, different kinds of waste. So deposited goods, mineral waste, for example. So flow properties which are there. So there's bulk waste, what is the mass. um, so flow has, different properties. If something is getting burnt, so there is a calorific value. So what's the calorific value of so if you are burning carbon, say cardboard, you'll have a different calorific value as compared to, say, if you are burning plastic, right, if you are burning waste. So for your whole process, you kind of, need to define, what exactly is going to be the whole process for cellulosic biomass, for example. And then, there are, characterization factors which can be there. Which impact category is it tied to? So once you have a process, the usage which is there, it is going to, get defined. I have too many windows open. Anyway, so we'll be defining, processes, we'll be having flows, and then, we'll be creating the project. uh, I see, time is running off. So we'll kind of, have, based on that, the results will be made available. So this is something, this whole process, which is there. There are some, YouTube channels which are already, explaining this in quite good detail. So OpenLC itself actually is also having, tutorials over here. So maybe, those can be, integrated, like looked into. But then the whole project will be created, and the results would be seen over here. So that's how, overall, this will be generated. So also, like, you might have to So I'll maybe delete a database and then actually show how to create a database. Maybe I'll delete cellulosic biomass. So good thing about databases is you can create databases. Uh, so you can create a new database, for example, like you can call this say, CB, cellulosic biomass, and save dummy electricity. Don't save. It's from the previous database. But this is a dummy empty database which is there, and within that you can restore a database. So when we restore this, we actually have the ZOLCA database which is there. So you might ask, where exactly is this ZOLCA coming from? So I have that also available. So it actually comes from something called as Nexus Open LCA. So all of you would actually need to have a registered account over here. Registration is free. Like rest of the login. So yeah, so registration. Yeah, registration is free, and then basically the database search which is there, it might have some free and paid databases. So if you see, there are these many free databases, 1,87,000 free databases, and there are many which are paid. So when I was looking for cellulosic biomass, very frankly, like it was for 750 CHF, and some of these things don't make sense. Like why spend the money? So I clicked on this, and like I got all the ones which were for zero price, and then there are some quirks which are there even with this database. So I actually wanted to have something from the agri footprint or agri by list, and basically from India. So um, so other look so I looked at countries, so I added India over here. So as you see, the price is less than one. Country is equal to India. And then I looked at e-convenient. So when I did this, I was hoping that I'll have a smaller data set. But when you actually see, like if I randomly select something over here, all these are paid. So what we understood is this search which is there, it's not working. So probably there is a quirk to it. There is a way to it. Maybe we can teach other how to search, or maybe we can report this and get this fixed. But we have one of these. Maybe we can go to downloads, get a downloaded version of this one. So we basically get a downloaded version. um, so I hope this works as not uh, not but and. So I tried to use this and as well, but it still did not work. So anyways, so going back to this, what you'll do is you will actually click on add to cart, and even if you go for free downloads, it will take you to the cart, and then it will have a quick checkout. Your fees would be zero in this case, and then it will actually start showing you in your downloads. So these are all the databases which kind of have taken from the website. So all of them are free. So I try to use the agribylase database for the specific purposes like which I was looking into. And like what I found is like it was not like it did not cover uh, many of the things. So yeah, so if you're switching between databases, it will require you to save. So you click on save. So by the way, Sankalp, like how are we doing on time? Like, do you think people want to continue, or do you think So any of the host, if they can.
Yes, sir.
So how do you think, should we, wrap this up, maybe, have another session some other day, some other time, or do you think we continue with this?
Sir. Yes, sir. You can continue for 10 more minutes.
Okay. Yeah. So I
After
think,
that, we
when
will
we
wrap
are
it up.
actually doing a live thing, sometimes you run into these errors. So we actually ran into this error. Yeah, for the next 10 minutes, I'll try and quickly wrap up by then. Um, so yeah, so when I saw this, like although the agribiolage database was there, it did not have product systems, and it had very few agricultural inputs which were kind of meeting the requirements which like I had. um, but still, there were things which are there, but it might not be very specific to the Indian conditions which are there. So so agribiolage, for example, like if you search for agribiolage, this is actually a French database which is getting used. So yeah, so I think, yeah, so, and many a times when you're searching for the database, you'll actually have to use Google Translate and try to figure out, what exactly the database is saying. So even though the language might be a barrier initially while searching, it might be helpful if you have a good database. So like what I found is, like after thoroughly searching all this whole database, it was not something which helped me with my processes and flows. So it was kind of, the whole thing was something which we needed to do from scratch. But I also felt that when the French can come with the agri-biolage database, why can't we Indians actually come up with our own database, work with our farmers and kind of get the information. So these are all avenues which are opening up. Like many of you students who are going to graduate tomorrow, they will be creating. So we don't need to all the time look forward to the government to actually always try and provide a solution. uh, some of you would create databases in future, and actually have them available, maybe even charge a fees, so that life becomes easier for the people who actually are going to do the LCA. So it's a blue ocean, I would say, for India. So definitely look forward to honing your skills within this space. With that, like I'll kind of also come towards the end. So in summary, what I'll say is, yeah, in summary, what I'll say is, there are various moving parts to an LCA. So using a software-based approach might be preferable, unless and until there are small projects you want to do. But we should understand that it's both an art and a science, and selecting a database requires some experimentation and sometimes some hand holding and experience. So I would suggest maybe since we have enough resources for our needs but not enough for our greed, we should come together and try and save the planet. So maybe take a pledge this environment day, and do something about it. So I'll invite you all, maybe connect with me. So like I'll have some inputs for all of you, some of the tools which I worked on. But also, like, I hope we can build a community and do something specifically for life cycle analysis. So with that, I'll like to conclude, and I'll be open for any questions which people might have. So
Thank you so much, sir, for enlightening us on this crucial issue, sir. As the data availability is quite restricted on such a vital topic, having knowledge about it helps us make better and more informed decisions and work more effectively by utilizing the currently available tools such as OpenLCA. and the same also. Now we would like to open the floor for discussion and Q&A session. So if anybody wants to ask any question, they can raise their hands.
So if nobody has questions, maybe I have some questions. So first of the thing which I have is, like I'd like to know like what the background of the group is, because one presentation doesn't make it complete. So I would firstly like to see how many people are technical and how many are non-technical within this group. Um, so if everybody can participate in this Slido. I'll just maybe share my screen with the Slido as well. So yeah, so this enthusiast, so I had put in as myself as an enthusiast, but there's some 18 people who actually entered the information. So so most of us are students over here. So this number is reducing. That means number of students are more. So if you can all click and vote. Okay, I think there are only few people who have voted, but yeah, roughly 90% of the people attending are students. So yep, 90% people are students, maybe more. Um, yeah, I'll close this, but I'll share the next multiple choice which is there. So which is are you technical or non-technical? Because that kind of so most of them are students, but like, are we from a technical background or were there any non-technicals as well? Okay, 3 people have voted as technical. I'll assume most of the students are technical itself. Um, okay, moving on to maybe the last one. And this is going to be an interesting one, I promise. So this is going to test you. Please don't use Google search or Bing search for that matter. Sustainable development goals. So LCA is related to this, responsible consumption and production. But which sustainable development goal is this? SDG 1, 2, 10, 11, 12. Okay, somebody said SDG 1. Okay. 3 people said SDG 1. Okay. Oh, somebody said SDG 12. Okay, good. Great. So I think the result is like, okay, good. SDG 10. Somebody said SDG 10. SDG 12 is picking up. Okay, so for so yeah, clearly the answer is SDG 12. So responsible consumption of products is uh, responsible consumption and production is something which is covered under SDG 12. So LCAs are under SDG 12. So any presentations you have in future maybe could have this as like you can have a Slido, or maybe you can just mention like what you're doing is SDG 12. So with that, like I'll just mention thanks so much for giving me this opportunity. Looking forward to connect with many of you. So I'm just leaving my LinkedIn link over here as well. And
So we have some questions collected through the feedback form.
okay,
So yeah,
great.
so the question is, how can life cycle assessment be applied to service-based industries or sectors where physical products are not involved?
Right. So that's a good question. So a lot of companies which are there, BPO services, software. So those are actually doing these kind of projects. So what is the main input over there? The main input is the time and effort people put in, and then also like another item is the servers which are there. So we need to quantify like how many kilometers somebody is traveling, or if they are flying for work. TCS. I was working with TCS, so I went to Amsterdam from here. So like I took a flight. So like what is the carbon emissions of that flight? So that is one thing which is there. So if somebody is interested in that, there is a tool called as Neo Travel. So Neo is basically tied to a credit card company. So all travel requirements of companies typically are getting tied with this. So companies which are associated with 1.5 degree C climate change. So for example, when I was working with Veolia, they actually use Neo for travel, so that anybody who is traveling, for work, anybody who is staying in a hotel, they actually have the exact carbon footprint of that person. So in future, what will actually also happen is it's not just the carbon footprint of that person which is going to be there. It will be carbon footprint of cubicles. So there was a costing back in 2010 when I was leaving TCS. They actually had a cost per cubicle. So now when I studied in 2012 to 2014, carbon was used as a currency. So when carbon will be used as a currency, we will know what exactly is the carbon footprint for one cubicle which is going to be there. So how many employees you have, multiply by a carbon number is what will happen. But like if I was to maybe do a hotspots analysis, a lot of it also is going to get accounted apart from the travel which is there. Maybe 20 kilometers on Delhi Metro which I take, or somebody is driving a car. So all those inputs will be there. So your app will be live on your phone, on your work phone, and the kilometers or miles which you covered each day would be tracked through GPS, and that will add up. So that total system is coming up. The second thing which is there is from your data center and servers. So your data centers and servers are a big energy hog. I would say like within a building, when I was doing an energy audit, so around 70% of the energy was taken up by the data center itself. So it can be that huge. And I mean, so it requires two types of energy. One is for running the servers, but also almost an equal amount of energy, or maybe more, is sometimes used for cooling the data center. So there could be hotspot analysis of water, because for cooling water is required. So upstream, other impacts which could be there, say for example they are using a diesel generator for the power backup, and if somebody is working in Gurgaon, we know the power situation over there. So that all thing needs to be accounted. The SO2 which is from the diesel generator, the NOx emissions from the diesel generator. NOx are 1,000 times more potent than CO2. So it's not the CO2 emissions only we are taking care of. It's the CO2 equivalent which is there. All the other fugitives which are adding up. So so there are circuit breakers which are there. So this is one thing which is the biggest. So SF6 which is there, like some people might know within the group over here. So SF6 has the biggest carbon footprint. Like if I could ask the group, anybody knows the carbon footprint of sulfur hexafluoride? It's like 36,000 or 38,000 GWP. So that GWP of sulfur hexafluoride is huge. So any equipment which is getting used, for example, you have a building with 3,000 people or 5,000 people, like when I was working with TCS, we had buildings like that. We had our own power supply, which was, coming from outside. So they had circuit breakers. If those circuit breakers had sulfur hexafluoride, and if it was leaking, that means there is a problem over there. That is a very huge problem over there, which needs to be addressed. So all those, hotspots which are there, they need to be, accounted for and taken care of. So one more hotspot which comes to mind is like most of us, in our homes, we actually have, an air conditioner at home. So if an air conditioner is there, what happens with the AC is, maybe in the 3, 4, 5 years, the the gas leaks. So it might be R22, it might be R407, it could be, any of those gases which are there. So earlier they used to have chlorofluorocarbons, and now they have hydrofluorocarbons. So they are not just bad for the ozone layer, they are even, bad for the atmosphere. So they are, bad as far as the climate is concerned. So for example, R22, if I remember, was, like over 1,000 GWP. So and the other so the best um, refrigerant which is out there, it is also having 300 something GWP. So global warming potential of your cooling systems, they need to be taken care of. So in short, there should be an expert which should be involved in the whole process. Starting from having food delivered, or making food in house. Scope 2, scope 3, scope 1, what exactly is happening, that whole thing needs to be understood, and then only one can fully address this. So otherwise it will be a pre LCA, it would not be complete, but it will maybe give you a broad idea, but there could be some pieces which could be missed out as well. So need to sit with the people who have the real data. So hope it answers.
Thank you so much, sir, for your wonderful answer. Okay, so there is one more question.
Mm-hmm.
What are the potential sustainability challenges and benefits associated with the widespread adoption of electrical vehicles?
Widespread use of electrical what? Can you repeat?
Electrical vehicles.
Electrical meters?
Vehicles.
Uh,
Vehicles.
Oh, electric
mhm.
vehicles. Okay, so in my eyes, electric vehicles, like I've kind of seen, like I won't claim like I've seen it, but I've read about it. So the overall life cycle of electric vehicles, there was a recent report which came out, electric vehicles are bad, and it was in all the Indian media which was there. So I don't know where these news come from. So basic math, what is the energy efficiency of a thermal power plant? So around 35%, 30-35%. Or similarly, your internal combustion engine, it is not more than that, it's around 30-35% only. Like somebody can do the math, but broadly it's 30-35% is the efficiency of that whole process. But when you are using an electric motor, the efficiency of that motor is around 90-95%. So that efficiency is increased. Now the question might come is, what is the electric source which is there? So the electric source is also going to be inefficient. So we should understand that the electrical source which is there, when you have a smaller system, your emissions are more, you have more fugitives which are there. When you have a larger system, experts are actually taking care of making sure there are no losses which are happening. uh, there are like ton of things, like starting from friction reduction in with lubrication to whatnot, all the systems which are there, those are all taken very well taken care of upstream, which is with electricity production. And then like we are already transitioning towards a cleaner grid. So like there are different varying numbers over there, but around 12.5% of the energy which is there on the grid is clean. So that number will vary. During the day there will be more, and during the evening there will be less. So but overall, there is also hydroelectric dams which are there, dams which are providing electricity. So all those are actually contributing to a cleaner grid. And I think we should consider electric vehicles very strongly. So they are much cleaner than the upstream and downstream of the internal combustion engine vehicles. So, and like I think some of this misinformation might also come up in the news, because we have huge resources of lithium we have found. And it might be a conspiracy to kind of brainwash the youngsters into thinking in two directions. One direction, the youngsters might think it's good to have an EV, and in the other direction they might think it's not good to have an EV. So best thing will be to probably have a LCA for that, and maybe one of you could be doing it, and somebody like myself will be more than happy to help.
Thank you so much, sir. So with that, we end this session. So now I would like to express our deepest gratitude
Thank
to
you.
Mr. Nishant Arora, our esteemed guest, for gracing us with his presence at this life cycle analysis workshop. Mr. Nishant, your expertise and passion for environmental conservation has truly inspiring.
Thank you.
Throughout the workshop, Sir has shared valuable insights into the intricate world of sustainability, offering us a deeper understanding of the environmental challenges we face and the solution we can implement. Your dedication to creating a greener and more sustainable future has left an indelible mark on all of us. Thank you so much, sir, for being a part of the workshop.
Thank you. I really appreciate
Thank you,
you
sir.
guys having me over here, and Delhi Technological University as well as your group. So yeah, keep it up, and make sure like you have more experts come on the panel, and I'll be more than happy to speak again, maybe meet some of you in person. So yeah, reach out to me, connect, and I'll be more than happy to help with any way I can. So mostly I'm a renewable energy, clean energy expert. Work very detailed with that. LCA is something which like I've done a little bit, and I was into carbon reporting. So anything related to carbon reporting after an energy audit, or an energy transformation at a particular site, I can help with that. So maybe electric vehicles, which is there, for example, I could help probably with that. So there's something called as International IPMVP, so protocol for measurement and verification. So that's a protocol people could use for measurement and verification, and that would be extremely useful. So yeah, thanks for the opportunity, and wishing you all the very best. Thanks a lot.
Thank you so much, sir.
Yeah,
Thank you, sir.
have a good one. Bye bye.
Thank you.
Thank you all to the participants for your active participation and enthusiasm throughout this workshop. So the session is ended.